Right, the word of the day is function. Become a functional person. Right, and in mathematics today we're going to learn about the quadratic function. What is it? How to draw it? And all of those things. Right, so in grade 11 and grade 12 you will use f of x equals to ax squared plus bx plus c. That is the formula that you would use, and maybe another variant of it. Right, for A decides whether the graph will be concave up, this is now proper mathematics lingo, and or concave down. If it's positive, then it's concave up. If it's negative, it will be concave down. That's a smiley face or a frown. Right, A must have a value. It can't be 0. If it's a 0, then it will not be a quadratic function. Right, let's go to the grade 10 things that you know. If you had mathematics in grade 10, A here will still decide whether the graph will be smiling, concave up, or frowning, or sad, we would say, concave down if it's negative. Right, if we want to sketch a graph, there's certain things that we need to look for. So this is a mother graph, which means it will be the original graph. Okay, to sketch a graph, there are certain things that we need to look at. Now in this case, I think there could be 4. So it's an intercept. You need to determine the intercepts first, plural, x-intercepts and y-intercepts. Then you need to know what the shape is going to look like, and there we identify 2 shapes. And then the asymptotes, in this case it parabola or quadratic function does not have asymptotes. Now the last thing that you need to know, that it has a turning point. The graph actually turns around. Okay, so those are the things that we look for. Asymptotes will not be applicable in this case, so we need to look out for that. Okay, so I will determine my intercepts first, my y-intercept, and then I set x is equal to 0. And so now I substitute f of x is actually y, and then we put 0 in the place of x to the power of 2, and therefore y is equal to 0. Okay, and we write it in coordinate form, it's important. And then we do the x-intercept, and then we make y equal to 0. We set y equal to 0. This is just a notation that you need to use because you are making statements here. Equals to x to the power of 2, and then we know if we have a square root, we're going to square both sides to get rid of this to the exponent 2 there, and therefore x is equal to 0. And there we write it in coordinate form as well. Okay, so remember what your intercepts are. So when we get the graph, then we can plot it. See there, we have both points at 0 and 0, and that is our graph. This is the mother graph, the original graph, you could say. And so graph is positive, facing upwards, concave up. So let's do 2 things. Let's find the domain of this graph, and it's technically a thing that most students struggle with. Let me simplify it for you. So domain refers to the x-axis. So we identify the x-axis of the graph first, and then you ask yourself, how far does it go to the left on the negative numbers, and how far does it go to the right with the positive numbers? So let's start with the right hand side. You can see here the graph has arrows on top, which means it's infinitely going or infinitely increasing. So this graph will continue and continue and continue. So we can look at that and say that goes on the right, and now we move to the left. It goes infinitely to the left. So infinitely on the right means positive infinity. On the left, on the negative numbers, it will be negative infinity. So now we can say x is an element of, now we use a circular bracket because it does not include that value. So negative infinity and positive infinity. If it was a number like 1,000 or 100, we would have used square brackets, but we use it simpler. We can also say x is an element of real numbers, and there we're done. That is the domain, and that is how easy it is, people. Drawing these arrows shows you actually where the graph goes. Right, let's try the range. The range for this graph, which axis are we going to look at? The y-axis. Okay, you need to look at the y-axis. You ask yourself the same question: how far does the graph go on the y-axis? Does it have a starting point? Does it start somewhere? Does it finish somewhere? So those are things that you ask yourself, basically. Right, on the y-axis, you see there it goes up, but it doesn't have basically like a starting point from that, doesn't continue all the way to the bottom on the negative numbers. So here we can see it starts at 0. So what you can do is you can write y. It starts at 0, right? Now you can write y and 0 next to each other. Now in between, I'm asking you, is it going to be greater than 0 or is it going to be less than 0? Does the graph go higher than what 0 is, or does it go lower to the negative numbers? So what do you say? It is greater, obviously. Right, so let's go to the second one. G of x equals to x squared minus 4. Let's determine the intercepts. Right. Then you must also know what the shape is going to be. And then you also need to know the turning point. We don't use asymptotes in this case, as previously stated. It is not a hyperbola or an exponential graph. Right. Turning point is easy to determine. It is simply just a y-intercept. So in -4 and 0 here. So let's determine the y-intercept first. You set x equals to 0. And then we say y is equal to 0 to the power of 2 minus 4. Y is equal to -4. And then -0 and -4 is my coordinate points. Let's do the x-intercepts. X-intercept, make y equal to 0. And we substitute. Remember, x must have two answers. So it will be x squared minus 4. There's two ways that we can do this. So the first way is simply to do the basic algebra method. We transpose the 4 over, it becomes a positive 4. And therefore x is plus minus 2. The way you can do it as well, you can factorize, just because it's the difference between squares. And so it will be x minus 2 or x plus 2 and minus 2. Either way can work, right? And then we put both brackets equal to 0 and we solve it. And then x is equal to -2 or x is equal to 2. And that's basically how you do that. Simple and easy both ways. Right, we write down the coordinates, -2 and 0, and then 2 and 0 as well. Right, so now you need to know what your intercepts are. And the shape, obviously, that's going to be positive. And so let's take it to the graph and actually indicate it on the figure. Okay, here's our graph. We can see there we have our points where it intersects the x-axis and then once on the y-axis. Let's write down our points. It's 2 and 0. And it's -2 and 0 there on the left. And at the bottom it will be 0 and -4. And there we have all our intercepts. Right. Now, let's find the domain here. But now it should be easier to you. We simply know that it's going to increase on the right hand side, all the numbers on the right hand side of the x-axis, and then all the numbers on the left. So it's going to be positive infinity and negative infinity. And we can simply say x is an element of real numbers because it includes all the positive numbers and all the negative numbers. And there we go. That's easy. Let's go to the range. Range, we can see there's a starting point, thereby 0 and -4. There's our starting point, and we can see that it's going to increase from there. Right, so simply we can just write down y and -4, and we can see obviously in this case it's going to be greater than -4. And that's how easy the range is, people. You can do it too. Now here we have a grade 11 or grade 12 quadratic function. We determine our intercepts first. We set x is equal to 0. And therefore it's going to be 0 squared minus 0 minus 6. And we can obviously say y is equal to -6. And our intercept will be, our coordinate point is 0 and -6. So that's our first point. Easy. Right, let's do the x-intercept. So x-intercept, you set your y equal to 0. So it's going to be 0 equals to x squared minus x minus 6. And yet again, we have two ways of doing this. So we can factorize it first of all. And by now you guys are experts in factorizing, or rather good at it. Let me not overuse the word. So x minus 3 and x plus 2. So if you minus 3 plus 2 gives me the middle term. And therefore I know it's right. So we put both brackets equal to 0. And then x is equal to 3 or x is equal to -2. And there we go. That's my two x-intercepts. Then there is another way. So I'm writing in coordinate form first. Then there's another way we can do it. And by now you should have learned this formula. It's called the quadratic formula. Minus b plus minus square root b squared minus 4ac over 2a. And now we can substitute. Now this is quite easy, but when we look at the trinomial we have there, we always write it. Look at the standard form to basically interpret where the numbers should come from. So we can see minus b is our second term. It's going to be -1, right? A square root minus b minus 1 squared minus 4, 1, and -6 over our coefficient of a is 1, or x is 1, so 2, 1, there we go. And then x is equal to 3, or x is equal to -2. And there we go. And that's how easy it is. Now these are our intercepts. So now we apply the intercepts to the graph itself. So now you need to remember that we have a y-intercept. It is 0 and -6. And our x-intercept is 3 and 0 and -2 and 0. And so now we take all of this information to the graph. But before we do that, we're missing something. And it is our turning point. Right. Turning point is minus b over 2a. This is our x value of the turning point. So a turning point is a coordinate. So it must have an x value and a y value. So x is therefore equal to our b is -1. So we substitute it in brackets just to be safe. And our a is 1. So it's 2 times 1. So x is equal to a half 1 over 2. Right. And so now to get the y value of the turning point, we need to substitute the x value into the original equation. And so we put it in brackets, a half to the power of 2 minus a half in brackets. And then minus 6. And then y is equal to -25 over 4. Right, now let's take our information there. It can also be written as -6,25. So just so that you can judge with your eye as to if the graph that I've drawn here is going to be correct. So that's our coordinates, a half and -25 over 4. And here we have our graph. Right. Remember my intercepts. That's going to be -2 and 0. And my intercept on the x-intercept on the right is going to be 3 and 0. My y-intercept is going to be 0 and -6. And then my turning point, and you see there it's a half. And then it's after 6, so that could possibly hold as -6,25, or we write in the fraction when we indicated on the figure, -25/4. There we go. So that's basically my figure, and that's what you can see here. So that's all the information we need to simply just draw the sketch. So you're going to be asked to draw some sketches in the exam. However, sometimes it will be a parabola, other times it will be a hyperbole. So let's determine the range. Now, this should be easy by now. We look at our starting point. It's going to be, we write down the y and -25/4. That's our starting point. So we can obviously see that it is greater or smaller? Greater. There we go. And that's our range. 2 marks given to you. Let's determine the domain. Right. We know that this will be on the x-axis. So this one continues infinitely, and we can simply just state x is an element of real numbers because it moves all the way to the right, all the positive numbers and all the negative numbers. And there we go.